Welcome to our next lesson in real numbers. The first problem show that for every positive even integer of the form 2q and that every positive integer of the form 2q plus 1. So we'll just take a sample. Let a be any positive integer and b is equal to no 2. So a is equal to bq plus r. Now r is less than b. So we'll apply Euclid's logarithm. So what can be the a? Now a can be, see now r is equal to 0 or 1 because it is less than 2. Therefore a is equal to either 2q plus 0 or 2q plus 1. So this is a direct application of Euclid's logarithm for numbers. So we'll put next problem. So find the highest common factor for these two HCF. So its highest common factor. So it is 420, 130. We know 10 is one of the factors. Highest factor is if you divide by 10. So we know it can be only 10. If you divide 130 by 10, you get 13. It is an odd number. So, but we will do by Euclid's method. What is the Euclid's method? Now, this 420 we have to divide by 130. So, what is the method? 420 is equal to 130 multiplied by. So, how much we can multiply by 3? It is 390, plus remaining is 30. 130 we know where to factorize. 130 is equal to 30 multiplied by 4 plus remaining is it's 10. Again, what about this 30? 30 is equal to 10 multiplied by 3 plus 0. So now this 10 is the highest common factor by Euclid's logarithm. So it is first line is divided by a smaller number of the 2. So in these two, which is small number divided by that number. Next, so we will try to divide 130 by 30, whatever remain in the first one. Next, 30 divided by the remainder. So this goes next line. Now the remainder is 0. So this 10 is the factor, highest common factor. So we'll do some more problems just to be familiarized with this method. So 135 and 225. So 225 is equal to 135 multiplied by 1 plus remaining is 90. This what about you take now 90. 90 is equal to, oh sorry, it's not 90. So now you take the 135 is equal to remainder of the first line multiplied by 1 plus 45. 90 plus 45 is 135. So we take 90. 90 is equal to 45 multiplied by 2 plus 0. Remainder is 0. So 45 is the highest common factor. 45 is the, let's see, we can try the older method also. You divide by 5, we get two terms. If you divide by 5, what you get? First is 2 5s are 10, 35 it is 27. Next is 225 is 5 multiplied by 4 5s are 20, 25 5. So with 27 5, 9 is common. So 9 5s are 45. 45 is the highest common factor. So now we will try adapt little slightly difficult problem. So what is the highest factor between 38220 and 196? So what is the first step? You divide 38220 by 190. 196 is into how much? 196. So we will divide and check. 382. Now we have divided by 196 minus. Now it's 1. 186 the remaining. Oh, it is 2. Another 2 we have to add. Now next is it is, so we'll try with 9. So 1764 minus 8. So 980. Now if you multiply by 5, I think it's 5 6 are 30. 3 5 9s are 48 plus 3 48. 4 5 1s are 5 plus 4. So 195. 196 multiplied by 195. And remainder is plus 0. Therefore 196 is the highest common factor. So we'll go to our next problem. Find the highest factor with 867 and 255. So 867 is equal to 255. Multiply how much we can, shall we try 3 times? 3. So 867 multiply 3 times, 3 5s are 15. 1 3 5s are 15 plus 1 16. 1 3 2s are 6 plus 1 7. plus 102. Now 255 is equal to 102 multiplied by 2 plus 204. If you minus, it is 51. Now 102 is equal to 51 multiplied by 2 plus 0. Therefore 51 is the HCF. Highest common factor. Okay. So we can try by our traditional method and also compare. Okay, next problem. Show that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5 where q is some integer. So he is talking about any positive odd integer of the form. Now what can be the or? Now or remaining factor has to be 1, 3 or 5. Otherwise A will become even. Now A is equal to, you are factoring B multiplied by some Q plus even number means the remainder is even. Then A will become even. Why? Let us take an example. 4 multiplied by 5, 20 plus 2 means it becomes 22. 3 multiplied by 20. For any positive odd integer is of the form 6q plus 1. Sorry, the 6 is fixed. 6 is fixed. 6 multiplied by something is always even number because 6 is there. 6 multiplied by any number. This is an even number. If you add another even number, totally is even. Therefore, A is equal to 6q plus 1 means this is an even number. This will, if you add 1, become add. If you add 2, become even. If you add 3, it's an odd. If you do 6 plus 2, it becomes even. So ruled out. If 6u plus 3, it is odd. The 6q is even. Why 6q is even? This is a 6, we can take it as 2 multiplied by 3. So 1, 2, you are multiplying something by 2. 6q plus 3 is odd. Similarly, 6q plus 5 is odd. 6q plus 4, 6q plus 6 it cannot come because r is less than 6. So this is also even. Therefore, these two are the answer. The answer he is giving is just to asking us to apply the Euclid's formula. A is equal to, no, B is 6, Q plus R. R is less than 6. So apply this logic. So with this, we come to the end of this real numbers chapter. So in this chapter we are trying to use the Euclid's formula and how practically we can apply. And this is how to find the highest common factor between two numbers when the numbers are odd or big. Numbers are big also we can easily find out. So we will do more problems in the next lesson. Now, so what did you notice in this? Finding the highest common factor. First, we divide the bigger number by smaller number. Next, we take the smaller number, divide by the whatever balance left out. So we are getting new balance. So again, 30. Now this 30 we are dividing by balance of the previous one. So we get now till balance becomes 0. Now 10 is the highest common factor between 420 and 130. Divide smaller number first. Next, smaller number you divide. Divide by the remainder of the previous line. Remainder of first one. So we repeat the same process till you get till the remainder becomes 0 and we get the highest common factor. Now please try to repeat the problems till you understand and give us a feedback. So thank you for listening.